So welcome to State Academia. Today we are going to talk about the introduction to this course, which is Calculus 1. So I'll just write that I'm going to introduce Calculus 1. And what exactly does Calculus 1 entail? Calculus 1 entails aspects of differentiation. So we shall learn the techniques of differentiation, which this is going to be the main content of the course. Of course, some of the methods of differentiation I'm going to cover is we shall begin with implicit differentiation. Implicit differentiation. We shall perform the power rule differentiation. And then we can also have differentiation, power rule differentiation. And then, okay, of course, we can differentiate through first principles. And we shall learn all these methods. So differentiation through first principles. And at the end of the day, differentiation is basically a rate of change. So rate of change. Of course, I'm going to introduce you guys to say all these techniques that you are going to use. Okay. All right. So the first thing, let me just introduce you this book here. This is SMP Advanced Table, third edition. So it's by Cambridge. So this is the one that we'll be using. And of importance, I think we'll be using this page here. Let me see. It should be somewhere here. Yeah, differentiation. We shall use this page. This page. Yeah, this is page 9 of this SMP table. So this is where it's telling us that definition and formulae. So, and we have the functions here, and we have the derivatives. So you can see that the derivatives of a function are denoted by a prime letter there, something like a small dash. So if a function is given by f of x, its derivative, okay, which derivative can also be written d over dx, all right, is usually denoted as f prime of x, all right. So x basically is nothing but a variable, okay, all right. A function basically it's what I can say is that it is what is made up of variables. So for example, if you say f of x is equals to 2x cubed plus 5, this means that this one, which is the function, is made up of x. All right. But if somebody writes for you 2y cubed plus 6, then this is f of y, because it is made up of y and not x. All right. And if somebody comes and tells you it's we have an equation, it is x raised to power 4 plus 5y plus 2z, then this function basically is made up of what? It's a function made up of x, y, and z. All right. Yeah. So basically, the things with functions, basically this is it. A function basically it can be an equation. All right. So that equation that describes the characteristics of a particular block or a plant, because okay, for engineering students, you realize that functions, when you have a plant here, it can either be a plant or a process. It's usually given, this plant or process is usually given an input, usually has an input, okay? And you get a desired output after you've given it an input, all right? So this plant or process, this is what we can say is a function, okay? So for example, if this plant, the function is given as f of x is equals to, let's say f of x is equal to 2x squared. So this means if you give it an input xi, which is an input, yeah, and you give that the input x a value, let's say maybe voltage of 4 volts, isn't it? We expect that the output here will be 2 times 4 squared, okay, which is 2 times 16, which we're going to get 32. So basically, whatever transformation that happens to an input to produce an output, that is what you call a function. So the function is what is in between the input and the output. Generally, that's what I'll say, all right? So even in this equation here, okay? So even in this equation, this is an output, okay? While the input is an x. So if you put a value 5 here, if you put 5, then you're going to get a definite value of an input, all right? So this one basically describes a process until when you get a definite value that you're going to put to x, which is an input, then it's going to give you an output. Otherwise, it refers to a process. Okay? Then now, x, y, z, you can use whatever letter that you're using. Okay? So these are unknowns, or these are values that can take any form from 0, negative numbers, whatever type of numbers that can be here. So these that can change values or can take any types of values, these are what we call variables. All right, so those are what we call variables. So for variables, it can be the variable can be x, it can be y, it can be z, it can be k, l, m, whatever. So we don't have any fixated form of taking a variable, right? So it is as simple as, for example, now if you have a process, let me just do this so that you can have room. So if we have a process that is governed by the function f of x is equals to 3x squared, all right, and you give it an input whereby x is 6, what do you think is going to be the answer? The answer is you just take the value of 6 and put it to where x is. So then now it becomes, since we know x and it's no longer variable, it becomes now f of 6, all right? And then you put 3, and then where there's x, put 6, like the way you did here, all right? So what is f of 6 in this case? F of 6 will be 3 times 6 squared, which is 36, and 3 times 36, what does that give you? 3 times 36, so the 18, 108, so it's 108. All right, yeah, so something of that kind. So these notations basically are used for engineering, mathematics, and everything, and any person who is going to do calculus 1 or calculus 2, calculus 3 until calculus 4, these are the things that you are going to come across. So it is important that you grasp these basics. So for this first lesson, I'm going to give us a test, a small test, so that you can check with yourself if you have understood what you have been told today. So I will give you a test that I'm going to solve with you. So solve. So the question is for you to solve. Okay, solve the following. Don't mind my handwriting. Solve the following. Solve the following. So you have f of x, y, z is equals to x squared plus 2y plus 3z, where x is equals to 3, y is equals to 4, and z is equals to 1. So what is the answer in this situation? So if you want to solve this one, so I'm going to give you a second, or just pause the video and solve it, and then we solve it together. All right, so I hope you've solved it. So let's see if that is what you've done. So then it becomes f of 3, f of 4, and z of 1 is going to be given by x squared, which is now going to be 3 squared, all right, plus 2y, so it will be 2 times 4, plus 3z, so it's going to be 3 times 1, all right, something of that kind. Then here you are going to give us 9 plus 8 plus 3, isn't it? So it's going to give us how many? 17 plus 3, which is equals to 20. So this is the answer. So if you got your answer as 20, then you are actually good. All right, now sometimes this f of x is going to be used interchangeably with y. So for example, you can be told y is equals to 3x squared plus 2. So find y when x, so find y when x is equals to 1. So then you're going to just substitute, same thing, y is equals to 3, 1 squared plus 2. So you're going to get 3, because 1 squared is 1, plus 2, you're going to get 5. And you still get the answer correct. Okay. All right. So the other thing that I would like to talk about is basically the techniques of differentiation. So differentiation happens with using different techniques. Yeah, there are different techniques that are used for carrying out differentiation, and some of them is first principles, differentiation through first principles, and that differentiations by first principles is what is given definition of the differentiation on the SMP table, whereby I told if f of x is this one, this tends to that, blah blah blah. So this basically, this is the first principles definition of differentiation. Okay, so what it means is that you get a change of the output over the change in the input. So this is a rate of change, isn't it? So if those of you who have done engineering or physics in high school, you realize if when you have something of this change in output and change in input, you're going to get a rate of change, which in this case here, we usually call it the differentiation, which is given by dy or dx, all right? All right? Or as I said, f prime of x, something of that kind. So those definitions are actually the same. And like I'll tell you, x usually denotes an input and y mostly denotes an output. But don't worry about this. This is nothing for you to worry, because we want you to develop slowly and in a good way, that you are going to have a better understanding for this unit. So then I'm going to leave you with some few questions to test your understanding. Just some few questions, just very simple questions to show you how easy it is to do differentiation, right? Because people think it's so difficult. So I'll say one. The first question here is solve for y. Y is equals to 7x plus 6. 2. Y is equals to exponential x plus 3. Then number 3, y is equals to natural log of natural log. Y is equals to natural log of x plus 10. Then I'm going to give you another one. Y is equals to the cosine of x squared. Then for this condition, for this equation, x is equals to 10. For this equation, x, I'll just put that. For this equation number 2, x is 100. For this equation number 3, x is 10 squared. And then for this one, x is equals to pi. So I want you to solve these ones very fast. So you pause your video and then solve it. All right. So for the solution of this one, I am going to do for you number 1, and then solution for number 3, 4. This one I'll demonstrate using a calculator. All right. So for number 1, it's simple. You just substitute because you've been told x is 10. So what you're going to do is that you're going to say for number 1 solution now. Number 1. So you will have, let's say you'll have y is equals to 7 times 10, isn't it, plus 6. So y is 76. Right. Number 2, y is equals to ex plus 3, and you're told whatever. You're told that y is equals to exponential. So what x now, you've been told that x is 100, so it will be exponential 100 plus 3, isn't it? So now you have to use a calculator. So if I use a calculator from my side, I'm going to introduce you guys to calculators here, so that and I'm going to demonstrate to you how I'm arriving at these solutions, so that when it comes to that point, we are able to show you. All right. So just a moment, so that I can get my calculator here. I didn't really thought I would need this calculator, but I think it will be easier if I can show you guys. I'm going to demonstrate to you how to use the calculator and introduce you to a calculator. And I don't want these videos to be long. Maximum 20 minutes, right? Maximum 20 minutes, so that you are able to follow these lessons easily. So exponential, using a calculator, I can just take the exponential term. So I'll go to shift. Will I need to do that? Okay. So for me to get that exponential term, it is not difficult. Don't worry, I'm still getting my calculator. So okay, I've already gotten it. So I'll go to shift, and I'll go to this one. Okay. So it's exponential 100. And then plus 3. There are some things you have to be careful with when you're using this calculator. So I will definitely demonstrate to you, so that some of these not remain as powers. So for me, I'm getting my answer to be 2.68811 times 10 raised to power 43. Okay. So then you proceed to number 3. Again, number 3, just substitute. So you'll get y is equals to ln. 10 squared is 100, isn't it? So 100 plus 10, isn't it? So you're going to get y is equals to ln 110, which is going to give you what? If I use this one again, use a calculator, 110, and it gives you 4.7, 2 zeros for 803,666. Then also remember, sometimes you can be given instructions that you write only to 2 significant figures. So maybe the answer will be 4.7, correct to 2 significant figures. So significant figures we abbreviate as SF, significant figures. So then we go to number 4. Y is equals to cos. So it will be cos pi squared. So this one you can just come here and say y, then shift pi, then square it, then evaluate. So I'm getting it as a 0.9852 as my answer. So be sure to get these answers, and if I've made a mistake, you can always correct me. No, I'm also a human being. I might be an instructor, but I'm also a human being. So that's it for this lesson. So I hope you've enjoyed it, and let's meet in the next lesson. We'll be talking about some of the techniques of differentiation. So thank you.